Okay, so this example, you'll notice there's three terms in the first parentheses. What do we call that three-term polynomial? What's it called? Trinomial. And then there's a factor, so remember these parentheses indicate multiplication, and there's a factor, k times 5. What's the name of that polynomial? How many terms does it have? 2, and so it's a what form? Binomial. Bi means 2, tri means 3. Now, you could multiply this order doesn't matter, but I would like you to rearrange it. Let's put the binomial first, and the trinomial second. And we're not doing anything different today, it's just that we have one more term to distribute these two terms to. So nothing new on this part. The word problems are going to be the newest part. We did do one word problem yesterday, and we're going to do another one today. I'm going to help you set up the other one today. So k times k squared. What is k times k squared? Can you tell me what that is, Peyton? If you're not sure, look at the cheat sheet on the board I just wrote. Yes, k to the third power is how we read that. And so k goes to the k squared, k goes to the negative 5. What's this coefficient on here if we don't see it, Naya? 1. So remember, when you're multiplying these terms, number times number, variable times variable. So 1 times negative 5, that's minus 5 or negative 5, right? And k times k. What's k times k, Jeremiah? Use the cheat sheet if you need it. K squared. Let me hear you say k squared. Or k to the second power. Either of those work. Now we've got k times 2. Now, number times number, so that's plus 2. I don't have anything to multiply that k by, so it just comes along for the ride. Everybody with me? All right, I'm going to slide that over. Okay, so I distributed the first term of the binomial. Now I'm going to distribute the second term. I really would love for you to draw these arrows. These arrows help you keep organized. Make sure you're not forgetting anything. So the negative 5, I'm going to draw this arrow on the bottom. So negative 5 times k squared. What's the coefficient on that k squared if you don't see it? Brandon? What's the coefficient on k squared if you don't see it? 1, right. So 1 times 1, so positive 1, but we're not going to write that positive 1, right? What's k times k squared, Brooklyn? What's k times k squared? Remember, we got a cheat sheet on the board. What's k times k squared? Not 3. What's k times k squared? There's not a 3 in that, right? Look at the board, honey. Remember we did that. I gave you a cheat sheet. You need to memorize those if you don't know them. We're doing k, I lost my track. Oh, sorry. Oh, what am I doing? I got distracted. So we're doing negative 5 times k squared. So we said that's a 1. So negative 5 times 1, that's what, Brooklyn? What kind of 5? Yes, negative 5. And do we need to put the k squared there? Yes. Now it's negative 5 times negative 5k. Number times number. So negative 5 times negative 5, I'm imploring you to use your calculator. 5 negative button times 5 negative button, you'll see that's a positive 25. And if I don't have anything else to multiply the k by, I just bring the k along. Negative 5 times positive 2. So you see that on your calculator, you'll find that it's negative 10. Alright, I got a little distracted. I'm going to check my work and make sure. So I did negative 5 times k squared. That's negative 5k squared. Negative 5 times negative 5k. That's 25k. And negative 5 times 2. Okay, I think I'm good. K squared times k, k cubed. Negative 5k. Alright. like yesterday, the first thing we do is we distribute. We've done that. We've distributed the first two terms here to all three terms and the other factor. Now we're going to combine like terms. I suggest you go through and mark everything that has the same variable with the same exponent. I'm going to start one line under k cubed. There are no other k cubes, so I'm not going to mark anything else like that. The next one is a k squared, and there's another k squared, so I'm squiggling that. I know those are going to go together. I can combine those. Now I've got k's. I need another, I'll put 2 lines there, 2 lines there. I know those can be combined. And now I have a constant and no other constants. I'm going to put a dot, so that's going to be by itself. So remember, distribute, combine like terms, write in standard form. We can kind of do the write in standard form and combine like terms to start with. Which of these terms has the highest degree? K to the third power, that's right. So that one is going to go first. There's nothing to combine it with, so that goes first. What's the next highest degree? The k squares, right, yes. So now we're going to combine -5 minus 5k squared. That would be minus 10k squared. Remember, to combine like terms, you add or subtract the coefficients depending what the expression says. Now the next one, so what's the degree on this term? Okay, what's the degree on that? 1, that's right. So we're going to put the k's next, so 2k plus 25k, just add the coefficients, 27k. And if you have a bunch of terms, it's always a good idea to cross them out, make sure you include them in your answer, bring down the 10. Nothing else to combine. It is in order from greatest degree to least degree. Remember, this has a degree of 0, right? And that will be your final answer. So really very similar, just one extra term. Any questions, Kendall? Make sense, Keyshawn? Make sense, Anson? Okay. So we're going to do one more, and then I'll help you set up your word problem. So we're going to do example 2, t plus 8 times 3t squared plus 4t plus 5. So we're going to distribute the t, everything in here. All right, what's t times 3t squared? What's t times 3t squared? Annie? Perfect. And now we do the t times 4t. What's t times 4t? Anson? Perfect. Positive 4t squared. Now you distribute the t to the last term. What's t times 5, Jeremiah? So remember, number times number, variable times variable. What's the, say it again? Perfect. 5t. All right, so we've distributed the t to everything. Now I need to distribute the 8 to everything. What's 8 times 3t squared? Fatima? What's 8 times 3t squared? Perfect. And 8's got to be distributed to the 4t. What's 8 times 4t? To Corey? 8 times 4t. So remember, number times number, variable times variable. So what's 8 times 4 to Corey? 32. And we can't forget the t has to come along. And last but not least, constant times constant, 8 times 5. Use calculator if you're not sure, it's 40. So now we've distributed everything, so let's go through and mark our like terms. There's a t cubed. I'm going to give that a squiggle this time. There's no other t cubed. Here's a t squared. I'm going to give that 2 lines. Not a t squared. This one's a t squared. I'm going to give it 2 lines. That's all of those I have. The t's, I'm going to give the t's a dot. And I'm going to give the 4019. Alright, so these and these don't have anything to combine. Remember, the biggest degree, we want to put it first, and we don't have to rearrange the ends. 4t, what's 4t squared plus 24t squared? Alright, what's 4t squared plus 24t squared? Perfect. Mark says, what's 5t plus 32t, Brooklyn? When you're combining like terms, you add or subtract the coefficients. So what's 5? Say it again? 37 what? Yes, positive 37t. And nothing to combine the 40 with, so that is our final answer. Any questions? That's all the notes we're going to take. So right now, though, I want you to get out your worksheet from today. I'm going to help you set up the problems for the word problem. So we're going to look at 39 and 41 together. All right, so number 39 you have on your paper, so if those words aren't quite big enough, you have this on your paper. This is a medical center's rectangular parking lot, currently has a length of 30 meters and a width of 20 meters rather. The center plans to expand, that means make it bigger, right? Both the length and the width of the parking lot by 2x meters. What polynomial in standard form represents the area of the expanded parking lot? So what we're going to do is we're going to draw a diagram together. Alright, so let's start by drawing a rectangle. This is going to be our parking lot. You have to have this diagram on your homework to get credit for it. It tells us the length is 30 meters and the width is 20 meters. So I'm going to call this the length and this the width. So far, so good? Good? Okay. Now it says the center plans to expand both the length and the width of the parking lot by 2 meters. So we're going to add 2 to the length of the parking lot. So if we've got the length of 30 and the width of 20, and we're expanding by 2 meters, expanding means to add. We're increasing it, right? So the length is going to increase by 2x meters, not 2 meters. And the width is going to increase by the same, it says. Any questions about that? So basically, we're going to add 2x here, right? So that would stretch it out, and add 2x here. So this would extend this parking lot. Really this is the most important part, right? We need to know an expression that represents the expanded length and width. We talked yesterday about the area of a rectangle is its length times its width. So now you're just going to plug in the length times the width, and then you're going to combine like terms and write it in standard form, just like the other problems that we did yesterday and today. Right, so that is the only kind of weird part. I wanted to help you with that. You are going to have some word problems on your test. You will see the exact same kind of word problems that you're going to have on the test on your review worksheet. We'll have 2. Any questions on what you're supposed to do next? So you're plugging into this formula, the length and the width, and then you're rewriting it in standard, you're combining like terms, and then writing it in standard form. Any questions for me? Brandon, does that make sense? Does that make sense, Jaden? I thought. There it is. Okay, so 41 you have on your homework. So you're going to be adding, we are going to draw a diagram that represents this situation here. So this one is a little bit different. It says the height of a painting is twice its width. So we're going to draw a rectangle that represents our painting. Okay, and mine's going to be a sunset on the ocean. I'm quite the artist. All right, that's my painting. Make sense? I don't know the width of the length of this painting, but I know that the length, or the height rather, so we're going to say that the height is the same as the length. All right? The height, this is the height, this is the width. So we don't know what the width is. We're going to use W for our width. And if we know that the height is 2 times the width, we're just going to write that as 2W. Make sense? Any questions? That makes sense, Keyshawn? All right. Now it says you want a 3-inch wide wooden frame. So have you ever framed a picture before, guys? No? Anybody ever framed a picture before? Stick a picture in a frame? Okay, Swan has. That's good. All right, so we're going to take that picture and we're going to add a frame around it. And it says the frame is 3 inches wide. That means it's 3 inches wide all the way around it. All right, so there's 3 inches on the top, 3 inches on the bottom, 3 inches on each side. So I'm going to go ahead and add a frame here. Does that kind of look like a frame? This blue part in between here to be the frame. So this would be 3 inches. This would be 3 inches. From here to here would be 3 inches. And from here to here would be 3 inches. Does that make sense? Okay. So we've drawn a diagram. Now we're going to write a variable for the area of the frame alone. So I'm going to show you what we're talking about here. So we're talking about I'm going to draw this on this piece of paper and show you because I tried just explaining it in words. So this is going to be that's my painting, lovely, right? And this part is the frame. Does that make sense? So the question asked me not for the area of this whole thing. Okay? We want the area of just this outside part, the frame. Does that make sense, Anson? So we don't want to know, we don't want to include in our answer the area of our painting. So what we could do is we can find the area of our frame and subtract the area of our painting. Why would that work? Well, really what we're doing is we're just cutting out our painting. So I'm going to show you. If we were to subtract, subtracting is kind of the same as cutting something out. Would everybody agree? Does that make sense? Okay. So if I cut this painting out of here, what do we have left? What is that? That's just a frame, right? So that's why we find the area of the whole thing. And for our purposes, it's the area of the frame because we're using the length and the width of the frame. And then we have to subtract the area of the picture because the frame is not supposed to include the picture. So that's what we're going to do now. So we're going to write Our strategy for B is to find the area of the frame. Uh-oh. We're going to find the area of the frame, and then we're going to subtract the area of the painting. Does that make sense? So this is B. So to find the area of the frame, let's go ahead and remind ourselves, what are the dimensions of the frame? Well, what is the length? And what is the width? What are the dimensions of our painting? What is the length? And what is the width? We're going to do our painting first because our painting is the easiest one. We said the width is W. And the height, or the length, is 2W. So that's all you need to know here. So don't forget, your formula for area is length times width. So you're going to use this formula to find the area of the frame, use this formula to find the area of the painting, and then you're going to subtract them. Does that make sense, Bettina? That makes sense, Tracia? Okay. Now this one is a tricky one. What is the length of the frame? Or the height of the frame? So we know from here to here on the frame is 2W. Does that part make sense? Because from here to here on the painting is 2W. Does that make sense, Naya? So how wide is this part? It's 3 inches, right? This is 2W, this is 3 inches. What is the length of this part? We said all the way around. How wide is it, Tishan? 3 inches, right? So the height would be the 2W plus 3 here and plus 3 here. So it's 2W plus 6. Does that make sense? Ari, does that make sense? Andy, does that make sense? So what do you think our width is going to be? Well, our width from here to here on the frame is the same as the width of the painting, right? So how far is it from here to here? 3 inches all the way around, right? So 3 inches here. How far is it from here to here? 3 inches all the way around. So the width of our frame is the width of the painting plus 3 on each side, which is 6. So that's what you're going to use for your dimensions of your frame. And then you guys are going to do C on your own. Well, you're going to do B and C on your own. Yes. I think we have less than 10 minutes, Lee. Yeah. Sorry, buddy. All right. Any questions for me? Okay. You can't scan and submit your notes because I just realized I don't think I have a part 2 notes published, and I'm about to do that. I'll let you know when it's done. You can scan and submit. Right now, just work on your 8-3 odds that I gave you today.